Oo. So, ano. Pag ni-record ko to, saan ko to makukuha?
Sir, depende po sa inyo. Parang either locally save sa device or sa cloud.
Kasi I'm using yung UP account eh. So, sinabi lang nung nag-record ako, sabi record lang. Kasi doon sa iba kong Zoom, binibigyan ako sa cloud or di kaya sa computer. Teka nga.
Apo.
Nag-record lang siya eh. So, titingnan ko na lang mamaya kung anong mangyayari. Kasi may klase ako after nito, yung 137 ko, na unfortunately puno. Hindi ko alam anong inaano ng mga estudyante. Yung before nung easing, meron akong 23. Tapos si Dr. Ariola, 25. Tapos nang nag-usap kami, 25 ako, tapos siya 22. Sabi ko, asan yung isa? Nawala. Okay? So, since wala si Lauren, okay? So, hindi ko pa, as I told you, I have not what we call did the syllabus yet for this course, but okay, just by the course itself, maybe you have an idea about what is this course all about. Okay, so when we're talking about spectrochemical analysis, so ano ba naiisip nyo kapag spectrochemical analysis? So I think we will have more interaction dito sa course na to. Okay? So most likely okay lang sa inyo mag-meet tayo from from time to time para at least ma-utilize natin yung thing. Pag nakita ko yung PDF nito, I think meron kang makikita mga PDF ng mga lumang i-share ko sa inyo. Okay? So 232. So this is just spectrochemical analysis or methods of analysis. So you all know me. This is your second time with me. So the good thing right now is if I gave all of you an A, wala makakapigil sa akin. Okay? So lecture time, Wednesday, Friday, 10 a.m. to 11:30 p.m. AM yan ha, pucha. Magdamag tayo nito, online. Okay? At ito lagi yung gagamitin nating yung sa tawag nating Zoom link. So yung grading, iniisip ko nga, I think you decide ano bang gusto niyo, problem set or quizzes na lang. Okay, maybe you can decide it by next meeting. Okay? Konti lang naman kayo kasi ang problem set usually pag binigay sa inyo, essay type. Pero pag quizzes, okay? So malamang bigyan kayo ng mga multiple choice or true or false question. Okay? So depende na yan kung ano yung magiging usapan natin by the end. Then the final exam is a take home. And it will be given to you as soon as possible. So in paper, wag nyo na lang sabihin sa iba, meron kayong final exam. Okay? But you don't need to wait until the final exam. Pero I bet sa final exam yung isasubmit, sa day ng final exam yung isasubmit yung sagot nyo. Usually ganun nangyayari. Okay? It's always been like that. And then 20% would be paper. So itong paper, more on like a review paper. So ang ano dito is either techniques na pag-uusapan natin and or yung use ng techniques na yun sa particular sample. So if we can submit this as a publication, as review paper, mas maigi kahit sa local journal lang. Okay? So that means this is the one that will, what we call, you will spend time outside class. Ito naman problem set or quizzes, ibibigay ko yan sa inyo outside class art also. So the way that we're going to interact dito sa online is more on about yung principles ng different instrumentation. Okay? So yan lang muna yung parang info na ibibigay ko sa inyo. And today, ang aanuhin ko lang is some sort of spectrochemical analysis history. Okay? So short history kung paano ba na ano tong technique na to. So if you're going to talk about spectrochemical analysis, so usually Encyclopedia Britannica define it as the methods of chemical analysis that depend upon the measurement of the wavelength and the intensity of electromagnetic radiation. So ano yan, electromagnetic radiation yan? In simple term, ano yan? One word, 5 letter.
Light, sir.
Light. Okay? So, ito lang yung tinatawag natin interaction ng matter with light. Okay? Now, unfortunately, if we're going to look at this, yung history nito, hindi talaga doon sa interaction ng matter with light. It's more on studying yung tinatawag natin celestial entity, mga stars, mga sun, okay? But it is how light interact with those material, hindi talaga sa matter, okay? And maybe yung start nating ano dito ito na kay Newton. Okay? So, during that time, a guy named Christian Huygens, alam ko pang Gen Chem 2 Ano ni Christian Huygens kung nagturo kayo ng Gen Chem 2? Light is a what? 4-letter word. Light is a
Wave po.
wave. Okay? So kapag wave ka, ibig sabihin continuous yung property mo. Okay? So what Isaac Newton did, maybe it was during pandemic. So ginawa niya, nag-play around siya, okay, doon sa interaction ng light doon sa prisms. So parang inaano niya dito yung optics. Okay, because during that time, by the 17th century, yung technology ng optics, masyado na siyang developed. Okay? Meron ng high quality microscope. Through, I don't know if you know the history, yun si Robert Hooke. Okay? Yung mga microbiologists na Antoine Beim na Leeuwenhoek. Okay? Now, ang inaano nila niyan, yung refraction ng sunlight into colors by a prism has been observed, but hindi nila maintindihan. Diba? So maybe you're familiar with the prism. If you pass through the light, it will give you colors. Okay? So hindi nila maintindihan yun yung time na yun, kahit yung mga magagaling sa optics. Okay? It was generally thought that the pure white light was contaminated by gross matter to yield colors. So anong ginawa ni Newton? Okay? He investigate by cutting a pinhole in his window shade to let in the sunlight. And then it showed up on his wall as a round illuminated area. And when he refracted it by a prism, it turned into an oblong area of a rainbow color. Okay? So na-intriga siya dun sa change ng shape. So ginawa ni Newton, he cut a variety of holes of different sizes and shape, but no matter, okay, what is the shape of the original beam, okay, yung refracted light na nakukuha niya, nagiging oblong lang. So anong ginawa niya? Okay, so since nakikita niya sa first prism na nag-aano pa rin yung nag-oblong lang yung nakukuha niyang refracted light, he used a second prism. So what he did, he placed a second prism of the same type at the path of the light, and he was able to turn the colors back into the white light. So this shows that the white light, rather than being pure, was composed of a series of colors. Okay? So yung magandang ginawa ni Newton doon, yung experiment niya is na-refract niya yung light doon sa piece of wood. Okay? Kung nag-drill siya ng small hole. And the way he did is was able to obtain a beam of light with a pure color. And when he did that, he was able to show that the blue light, when it is refracted through a second prism, it's still giving you a blue light. And then the red light, okay, pag inano mo sa second prism, it will only give you red light. So the way that he looked at this is the angle. Okay, yung angle na nade-deflect yung light doon sa wall, dependent siya doon sa color. Ang term na ginamit niya doon is refrangibility. Okay, so yan yung unang term ng refraction. Refrangibility. Yun yung talagang word, exact word na ginamit niya, okay, sa pag-describe nung na-observe niya. Okay? And then what he do, he got a thin slice of gold leaf. It reflects the gold light from a candle. Now, Newton found out that it appears blue if viewed from behind. Pero yung colors ng word it was not revealed by the light, but it comes as the light itself. While the objects are variously qualified into reflect one sort of light into greater plenty, what we call greater plenty than the another. And he published it. Ito yung tinatawag nating first definition niya that light is made up of what? Gusto niyang i-debunk ito. He said that light is made up of particles. The exact word that he had is corpuscles. I don't know if this is the first time for you to hear the word corpuscles. Okay? So ang ano nito, ito yung naging parang idea ng division of light into photons. Okay? So ang main contribution niya is yung use niya ng multiple prism arrays, yung series ng prism. Okay? It was described when he published it in 1702 doon sa optics. At yan yung tinatawag natin ngayon, precursor ng tunable lasers. So we will have some discussions on lasers in the near future. Ano bang nagpagkakaintindi niyo pag laser? Anyone? Have you experienced using laser? I think as a teacher, meron. Yung laser pointer. That's the what we call simplest laser. And sometimes the color is what? Commonly it's red, but you can also have what color? Red lang ba yung na experience nyo?
Green.
Green. Right? So, ano ibig sabihin ng lasers? So usually kapag lasers ka, what can you say about laser in terms of the wavelength?
One wavelength na po siya.
Okay? One wavelength. O yung term natin na
Monochromatic.
Monochromatic. Okay? So pag tinatawag mong tunable lasers, so that means you can play around, okay, with the wavelength of the laser. So, yan it through the use of the prism. Okay? And they usually use it. So sometimes, double deflect mo or triple frequency mo, ikakat mo yung wavelength into a half or into a third. So parang nagiging tunable yung laser mo. Instead na monochromatic, you can use it at different wavelength. So yan yung main contribution ni Newton. Okay, although we know him as what? Saan natin alam si Newton? Siya yung tinatawag nating haligi ng classical physics. Okay? So, when you're talking about classical physics, ano ba usually pinag-aaralan mo doon? Yung mga big materials until Max Planck made his own physics, yung tinatawag na quantum physics na atomic or small level. Okay? Yung hindi ma-explain ng classical physics, i-explain ng quantum physics, yung boundary ng dalawang physics. Okay? Now, the next thing that we can have is Joseph von Fraunhofer. Okay? So here, tinatawag natin dito yung spectroscope and diffraction grating. Okay? So napaka-important nito when we go to what we call the components of our optical instrument. Okay? So Joseph von Fraunhofer, maybe we can call him as the father of spectrometer. Kasi kapag meron kang monochromator, ang ginagawa, okay, para malaman kung anong wavelength ang gagamitin mo, yung tinatawag na diffraction grating. Okay? So, Fraunhofer is a German physicist, and this is the thing, optician. So it deals with optics. Okay? So yung ginawa niya, yung spectrometer na inaano niya, believe it or not, it is used for astronomy. Kaya ang tawag nga sa kanya is astronomical spectroscopy. Yung founder siya ng field na yun. Okay? So ang ginawa niya is study the diffraction of light through this narrow slit. Okay? So when we study about the optical components, especially about the monochromators, dyan papasok yung contribution niya. Okay? So studying the diffraction of this light through the narrow slit was able to develop the earliest form of this diffraction grating. Okay? It is commonly found in all spectrometer. And he's given credit. I don't know if you have heard this Fraunhofer lines. It's not really chemistry, okay? Because the Fraunhofer lines are what? Yan yung tinatawag nating the dark lines doon sa sun spectrum. So noon, they use light, okay? Yung light na usually galing sa sunlight. Okay? So he solved many scientific and technical problems, especially with regards to what? Since he's an optician, so ano yung main instrument ng optician to study the sunlight? Okay? Yung sa paggawa ng telescope. Okay? So yan yung, we could say, one of the pioneers nung sa spectroscopy. And then, hindi na mawawala dito yung photographic process. Okay? So usually, they gave the credit to these two. So ang nagsimula niyan is si Joseph Nips. Okay? Now, together with his brother, okay, they developed this what we call, believe it or not, a gasoline-powered engines. Okay? And they make a lot of money on that what we call engine, the brother. Okay? And what happened is Nips in 1813 began to experiment yung tinatawag na lithography. And what he tried to do is he tried to make like a drawing out of it. Since hindi siya marunong mag-drawing, okay, at hindi siya makakuha ng proper lithographic stone locally, so parang gumawa siya ng paraan para mag-provide ng images automatically. So yung ginawa niya, nag-coat siya nung isang material with virus light-sensitive substances in an effort to copy superimpose engravings in sunlight. Okay? So ang attempt niya doon, way back in 1860, is the first attempt at photography. Ang tawag niya doon is heliography. Why? Bakit kaya ang term niya is heliography? Anyone? Ano yung kailangan niyang gamitin? May root word dyan. What's helio? Anong naisip niyo pag helio? Ha? So instead of photography noon, ang tawag niya is
Sunlight
heliography. So that's based on sunlight. So nag-try siya mag-develop using different chemicals. Okay? Parang meron siyang kinuhang photo image and he tried to expose the chemicals, okay, using the sunlight. So yun yung tinatawag natin heliography. Ang term nga na ginagamit doon is sun drawing. So parang meron siyang crude camera. Ingay na naman. Okay? So ang nangyari yan, he recorded the view of his workroom window at yun yung tinatawag na first photograph. Okay, I think the title is Lagras or Lagas, something na ganun, is a French word. Okay, so yun yung what we call first instance na ginawa niya. So yung chemical na ginamit niya is yung tinatawag na silver chloride. But the problem is was only partially able to fix the image. So ang ginawa niya, nag-try siya ng iba't ibang light sensitive material, okay, para ma-improve yung process, yung photographic process. Unfortunately, before he died, he was not able to develop it, but his son gave the technology to the other guy, okay, si Daguerre, and Daguerre was the one who was able to develop this photography that we have at this time. Okay, I don't know if you're familiar yung old pag-develop, alam niyo yung film? Naabutan niyo pa ba yun? O lahat kayo digital na lang ngayon? Because before, the camera that we have, at least during my time, so meron kang film, ilalagay mo dun sa sa camera, tapos yun yung pang-capture. And then what happened, you don't expose it, you open it in the dark, and then sa dark room, okay, i-develop mo yung picture mo. Usually, I don't know if you see some movies yung parang nilalaglag nila sa solution. Tapos pag angat nila, makikita mo yung picture na. Yung negative na meron ka is just a roll of film. Or if you have a movie, usually, yung yung pelikula ni Piolo Pascual? Lagarista ba yun? Yung taga-deliver siya ng I don't know, in the cinema, you will see that they have this roll of film. So, meron from one sinehan to another yung magde-deliver. Okay? So ganun yung pag-develop ng photography noon. Tapos na-develop into this moving camera, yung dati may ganyan pang tao yung iniikot nila yung black and white. Okay? Tapos ngayon yung parang yung video cam na lang. But right now, everything in the cell phone was we could do. So ganun yung yung thing. And again, light plays a very important role on it. Okay? Now here, Sir John Frederick Herschel. He is known for what? Maybe in your high school, you met him. Saan nyo na-met si what we call Herschel? Siya nag-discover ng planet na here in America. Ganito yung pag-pronounce nila. Uranus. But we call it Uranus, right? He is known there, okay, as the one who discovered this what we call planet. But his main contribution in spectrochemical analysis is he discovered this so-called infrared light. Okay, he discovered the existence of this infrared light. Again, sunlight uli, passing through the sunlight, passing sunlight through a glass prism in an experiment similar doon sa inaano mo pag meron kang light color. So what he observed, as the sunlight passed through the prism, it was dispersed in a rainbow of color that we called the spectrum. Okay? So pwedeng sabihin natin, yung main niya, aside from the infrared, yun yung tinatawag nating electromagnetic spectrum. Sa time ni, tawag dito yung Newton, ni-refract niya nila. Okay, but yung time ni Herschel, nung pinas nyo yung sunlight dun sa prism. So, yung color na nakikita natin, yung Roy G. Biv, okay, I hope you're still familiar with this one. Alin ba yung ano? Roy G. Biv. I think it's like this, right? Violet is the shortest, red is the longest. Okay, so yan yung tinatawag nating electromagnetic spectrum. But this is only what? This is that your so-called visible light. Shorter than that, anong meron ka? Still remember?
UV, sir.
Huh?
UV po.
UV. Longer than that, you have?
IR.
IR. Diba meron tayong tinatawag na mid-IR, long IR, okay? So that's a useful technique that they have. But during the time, ano niya yung existence nitong tinatawag natin infrared. And then, the next one are this. So, Kirchhoff, and maybe you know Bunsen, right? We name a burner after him. So what they did, okay, they used spectrochemical analysis to discover new elements like cesium, rubidium, tantalum, indium, helium, and gallium. Okay, in this time-consuming extensive research, which need not to be presented here in detail, it came out that the variety of compounds in which the metals were used, the difference in the chemical process of the flame, and the great difference between the temperature had no influence on the position of the spectral lines corresponding to the individual metal. So ito na yung mga line spectra. So maybe during the time, they have the line spectra, yung mga known, okay? And then when they look at some of these element containing compound, so they found out, oh, this is a different line spectra. So that may correspond to a new element. Okay? So yun yung contribution nitong dalawa. And then this one. Angstrom. Okay? So this is usually what? A unit of? Anong unit yung ginagamit nating angstrom? Anong unit of measurement?
Band length, sir.
Length, right? It's, I think, if I'm not mistaken, 10 to the negative 10. Okay? But what he did is he combined spectroscopy and photography. In fact, he is considered as one of the founders of this what we call spectroscopy. So yung ginawa niya, na-discover niya yung hydrogen doon sa sun's atmosphere. Okay? And the honor that he get is one of these unit of length was named after him. Okay? And then, dito pa rin tayo sa hydrogen, maybe you know him. Yung tinatawag na Balmer series. I don't know, meron yung tinatawag na spectroscope. So if you put it in an element light or lamp, you will see yung series. So sa Balmer series, okay, in-identify niya yung line spectra doon sa visible spectrum. Okay? And this is, I think, the basis of, who's that? Bohr. When he tried to describe the atom. Okay? The planetary model of the atom. So si Balmer, ang ginawa niya doon lang sa tinatawag natin hydrogen. Now, if you're going to look at this, if you're going to combine everything, lahat, most of the study that they have has something to do with ano tawag, heavenly bodies, matawag natin dyan, yung celestial heavenly bodies. Okay? Before they even develop this spectroscopy. Pero yan yung naging basis on how this spectroscopy came into being. Okay? Now, when we're talking about spectroscopic methods, we're talking about the way analyte. So analyte is the compound of interest and how it interacts with the electromagnetic radiation. Or we could put the analyte as the matter, okay, interacting with the light. Now, most of this method is based on the measurement of the light absorbed by a sample. Yan yung tinatawag nating absorption base. Okay, so this could be atomic absorption or molecular absorption. We're not going to do NMR. Okay, so ang main characteristics na gagawin natin dito is meron tayong molecular tsaka atomic. Okay, now in addition to this one, your molecular and atomic, it can be absorption based, it can be also emission based. Okay, so you can have a molecular emission, but it only happens when your sample is fluorescent. Okay, so the rest of the methods are generally based on the measurements of light emitted or scattered by a sample. So we have an atomic emission, okay, and a molecular emission, but usually molecular emission is only applicable doon sa fluorescent sample. Okay, IR can be described as what? Absorption based. Okay, Raman is what we call scatter. Okay, so yan yung different method, but I think I have a table about here that. So your spectroscopic method, as we put it in the electromagnetic radiation, so it can be any of these. And we're going to discuss most of this, pero mahina ako sa NMR. Okay, so we might focus more on the absorption. We can have some of this part, the X-ray. Okay, I have experience using the XRF. Then the absorption here. Then when you go to the ultraviolet light, there's an absorption, emission, and the fluorescence. And then we can go here on this vibrational spectroscopy. Okay, there's so-called microwave absorption, the ESR, electron spin. So if you're going to look at this, these are the type of the transition that you have. Okay, that's why nagtataka nga ako sa binigay sa aking material, they included their LCMS. But for me, I don't think LCMS is a spectroscopic method. Because if you're going to look at this, okay, ano yung interaction ng mass spec, okay, with respect to light, okay? And in some, you can also have what we call surface analysis. That's why I told myself when I asked Dr. Pradesh, pwede bang mag-develop ako ng sarili ko kasi I was able to borrow this Bible. This is usually the Bible of spectrochemical analysis. Sabi niya, no, you have to follow what is it that you have before given to you, kung ano daw yung material. No, but I think in my own opinion, I cannot consider mass spec, okay, as a spectroscopic method. Okay. Now, usually, what can you see in all of these spectroscopic methods? Since you're interacting your sample with light, so it's just obvious to say one of the material or component that you have is the so-called light source. And your light source depends on what transition you have. Ano ba yung gagamitin mo pang transition? Okay, you can have a strong light source, you can have a weak light source. So for instance, yung light source na ginagamit mo sa IR, hindi yung katulad na light source doon sa UVBs. Okay, hindi mo magagamit yung light source, let's say, no IR kapag gusto mo mag-Raman. You need a more powerful light source. Okay, so that's the thing that you're going to learn in this course. Okay, the theory that you have there. So as you could see there, here, all of them are light or spectroscopic method, and all of them we could say, oh, the component is almost the same. What's the only difference that you have here? If you're going to look at this one, it's almost the same as this. Okay? Ang arrangement lang ito, yung sample after ng wavelength selector. Ito, yung sample ay bago pumunta doon sa light source. So what do you think is this instrument? The first one. Anyone? Ano sa tingin niyo yan?
Sir.
Ha?
Spectrophotometer, sir.
Spectrophotometer. So usually we could say this is your UVBs. Pang-absorbance. How about the second one?
Fluorescence po, sir.
Okay. So you can see there's a fluorescence here. Okay, it's either the L shape that gave it away or meron din fluorescence na T shape. So pag T shape, meron kang same component of this on the other side. Okay. Now, you will know the reason why ganun yung format niya. Bakit hindi diretso gagaya ng spectrophotometer? Because you're trying to what? Look at the emission. So you cannot put directly the source. Okay? So the way that you're going to do is you have to observe it at a 90-degree angle. Kasi pag ginamit mo straight sa source, masusunog yung detector mo. And it happened to me. Namura ako ng advisor ko. But it is still in the T position. But the problem is the light source is a laser. So nasunog yung detector, yung CCD. Aba, malay ko ba? Sabi niya, buksan ko daw yung yung slit eh. Because you also have to be what we call, sometimes the detector that you have, if the light source is so much, it can burn your light source kahit na 90 what we call 90 degree angle. Okay? Kung masyadong fluorescent yung material mo. Unfortunately, we're using a fluorophore during that time. Kaya nagtataka kami, oh, ang taas ng reading, tapos biglang baba. Sabi namin, oh no, we messed up the thing. Napagalitan lang ang isang linggo. After that, okay na, gagamit namin uli. Bibili na ng panibago. Okay, now the last one, what is this? Kung mag-quiz tayo. Ano to? Tingnan nga.
AAS po ba?
Yep. Yung AAS. Okay. So usually yung sample, di ba, inaano muna natin siya, pinapainit. So either we use atomic absorption or atomic emission, we monitor it at a certain wavelength. Okay? Kasi ang nangyari doon, it will absorb at a certain wavelength and it's going to emit at a certain wavelength. Okay? So yun yung mga things na malalaman ninyo, and between an absorption and emission, which one is going to be more sensitive? Stuff like that. Okay? Unfortunately, nasira yung ibang yung photo nung spectroscopic method. But here, this is the one that we commonly use. Okay? And I think sa lab ni Andrea, maraming ganyan. Okay? Yung UVBs. And I think they use it, especially in clinics. If you have your blood sample, your urine sample. So each company, they have developed their own method. Okay, that when they use a particular substance, all they need is what? Measure the absorbance of that at a particular wavelength, and they can determine the amount. Automatic na yun nangyayari doon when they do what we call the assay. So I think that's what I have for now. So question. Marami pa yung time. Isang oras pa ba? Ano oras pa ba? Oh, mayroon pa tayong 40 minutes. But as I have told you last time, next meeting, we're not going to meet, but we're going to meet in my advisor's seminar. So I think, kailangan ba mag-ano dun? Mag-register?
Yes po, sir.
Sino ang sponsor nun? ChemSoc? Or I
Parang
see.
ChemStock or and ChemAA po ata.
Oh, alumni. Ito yun eh. No, she's my advisor. She's my PhD advisor. So I'm going to require this class and the next class dito. Saan na yun? Here. Sakto sa time natin eh, kaya wala akong choice. So it's 10 to 11:30 a.m. Wala namang bayad, di ba? Libre.
Opo, sir. Free po.
So this is the use of LCMS doon sa environmental chemistry. Ito pala yung magre-register. Hindi rin pa ako register eh. Magre-register na rin ako para makapasok. So imbis na mag-meet tayo sa sa class, we're going to meet here. Yeah, so makaka-register na. So tanong, meron ba kayong specific na method na gusto nyong isama? Tanong ko lang may lumalabas na sa watermark sa akin. Nakikita nyo ba yun?
Yes po, sir.
Bakit
Yung
may
email
ganun?
address po namin.
Yung nakikita nyo, email ad nyo.
Opo.
Ah,
Para in case po i-duplicate po namin. Accountable po kami doon. Parang ganun.
Hindi, annoying kasi.
Pwede po siyang tanggalin po ata sa settings, sir.
Paano tinatanggal yun? First time kong gumamit ng nung UP Zoom.
Opo. Hindi ko sure. Saan ba ito?
Alam ko si Mamigo ganun din. Sabi ko, ma'am, naano ako. And lumalabas yung email ad ko.
Yung host lang po makakatanggal nun, sir. Sa settings po ata.
Sa Zoom settings talaga, no? Siguro yung
Opo.
next class. Na
Tapos parang i-disable lang po yung
So
watermark.
pag pinost ko to, ang lalabas pangalan ko kasi ako yung nag-post. Ganun ba yun?
Atas, parang sir.
Email ad. So parang malalaman kung sino yung salarin. Kung mag-leak. So tanong. Any question under the sun?
Sir, sa Canvas din po tayo.
Saan nyo gusto? Alam mo, hindi ko pa alam kung paano yung hindi ko alam siguro sa bagal ng internet. Hindi ko ma-access yung sa bahay. Pero pag nasa school ako, na-access ko siya. Kaya nga, before dito, sabi ko, naku, baka meron pang pang-5 or pang-6 na student. So I have to make sure na 4 lang kayo. So binuksan ko yung Canvas, it took me an hour. Okay? I mean, yung 6. Yung Canvas ata nakakapasok ako. Pero I think mas okay ba sa Canvas? Para sa inyo?
Sa akin po okay lang po sa Canvas.
Kay Andrea, nag-Canvas ka na. Sa 2:30 natin, sa Canvas kayo kay Ma'am Ivy, di ba?
Yes po, sir.
Na hindi ko nakita. Ngayon lang ako nagkaroon ng account nung malaman nila na hindi ako makakasubmit ng grade sa 6 unless account ko or unless ako ang mag-input. Yun lang yung binigyan nila ako ng account. Okay? Kaya nga sabi ni Ma'am Abik, kasi naghihingi ako ng Canvas tapos yung Google form. I think ang inaano nila is kung ano ka, mga lecture natin. Okay. So, may tanong pa kayo. Before we call it a day. May klase ba kayo today? let's say after, because I don't think meron kayong klase before.
Ako, sir, may klase before.
Ah, meron? Anong oras
7 to
yun?
10.
Ha? 8
7
to
to 10, sir. 7 to 10.
10?
Lab.
Lab.
Apo.
Pero, may 7 ba? Ay, oo, may 7 to 10, 10 to 1 pala kami dati. Ano yun, Gen
Yes,
Chem?
Gen Chem, sir.
Ano palang status ng yung in person? Wala pa?
Wala pa po ulit. Pero magkaka-meeting daw po ng March 4. Parang
Paano
ito
na lang yung MS thesis nyo?
yun po.
Tagal-tagal pa naman, sir.
4 pa lang po kami ngayon eh.
I think, ilang taon ba yung MS ko? I started 99. Yeah, graduate ako 2003. Iniyak-iyak ko rin yung thesis ko. Yung puhunan ng thesis ko, luha at saka dugo. Kasi I don't know if you know the lectin. May lectin research kay Mamerka ako. So yung sample namin, ang assay dugo. So pupunta ako sa infirmary. Sabi ko, type O, tapos magpapakain ako ng type A, type B, type A. Mga estudyante ko pa yung iba. Anong type mo? Kasamahan mo ako pamerienda na lang. Yung iba nga ay parang, sir, takot daw ako mag-ano ng dugo. O siya, hindi na ito. Yep. Nahirapan. Kaya nga, I think, I don't know if you know it, most people, they don't finish their MS. They just proceed to take their PhD outside. Kasi hindi naman required. Pero ayaw ko sabihin sa'yo, magagalit sa atin si Ami.
So, sir, common trend siya sa mga previous instructors.
Just to give you an idea, I think when I went to IC, there are 8 of us. Ako yung pinakahuling lumabas papuntang US. But during that time, nagkapamilya ako. So, nagkaanak ako. Tapos ako lang ata nakatapos ng MS sa batch na yun. Yung parang pagdating ko nga sa US, lahat sila bago pa lang Friendster pa ata doon. Hey, welcome! At last, sama-sama na tayo dito. And as of now, lahat kami nandito. Pero meron kaming mga batch na nandyan hindi sa LB doon sa NCPC. I have a blackmate doon. Pero lahat ng kabatch ko na instructor diyan pumunta lahat dito sa US. And the good thing is sila yung parang ako lang ata sa academe. So if ever I have questions with advances in the industry, sabi nga nila, hindi na yan nagtatitrate. Sabi ko, paano pag nagka-brown out, pag inatake tayo, paano kaya mag-a-analyze? So you have to go back to titration kasi kahit walang kuryente, kaya dyan sa LB, kaya mong gawin. Uso pa rin brown out dyan, di ba? Buti na Andrea sa Taguig. Di ba sa ano ka? Kay Ma'am Mijares ka, di ba? Andrea, hindi.
Nag-resign na dun, sir.
Wala ka na doon. Saan ka na ngayon? Hindi ka na sa JEPCOR?
Hindi na po.
Sa JEPCOR, nagsimula sila noon. Parang ilang instrument lang din eh. I think nung time na nandyan ako, GCFID lang yung high-end nila eh. Tapos tinupad yung mga waste solid act. Basta ang daming mga yung required na may ganyang analysis. Okay? Sabi ko nga sa iba dyan kung may pera kayo, mag-pool kayo ng resources, maggawa kayo ng analytical service lab. Kikita kayo ng madami. Yung iba, titration lang ginagawa Hindi nga. Yun yung sabi ng kaibigan ko sa DOST Kaya daw sila kumikita kasi bawat planta, they have to show na nag-aano sila doon sa kung ano man yung act na yun, yung Municipal Waste Act. So, ang ano lang nun, yung basis lang din nila, yung Spectronic 20. It still exists. To tell you frankly. Reliable pa rin siya. Yun nga lang, number na. Kung analog yan, talagang ewan. if I'm not mistaken, yung first experiment, kung nag-137.1 ka, kasi nagturo din ako doon, I think yung chalk, ilalagay mo doon sa lalagyan, di ba? Di ba, Emil?
Tama, sir.
Yung pa rin ba ginagawa nun before nag-online?
Nung estudyante pa ako, ganun pa yung ginawa.
Tapos ano pa yun? Binubuksan namin ni Mikor yung pinapagalitan kami. Binubuksan namin yung cover. Sabi namin, para makita ninyo ano nangyayari sa loob. Because you will see yung color, nag-aano talaga siya. Kasi you seldom see scanning. Alam ko, diyan ko lang ata nakita yung double beam.
May double beam pa rin, sir.
May double, buhay pa rin yun. Okay. Dito, kahit may double beam, ini-ignore namin yung second, sabi namin, sayang yung cubette. So, sinisiro namin pareho, tapos nilalagyan na lang namin yung, yung sample. Yun yung bread and butter nung lab ko. Yung UVBs, absorbance, tapos yung IR, tsaka Raman. Okay. So, yan yung parang kasi ang hirap ng maintenance nung tawag dito, chromatography. Gaya ngayon, sabi namin yung pump, so hindi pa papalitan. So sabi okay na daw. Idigas lang daw yung yung sample. Kaya sabi ko, ewan. So sabi ko, titingnan namin sa experiment. So I'm teaching also instrumental lab. Wala yung instrumental lecture ko, yung hawak ng isang professor. So I think, so see you on Friday on Dr. Aga's lecture. Doon na lang tayo magkita-kita. Okay? Anong oras yung kay Dr. Manalo yung class? Anong araw?
Ay,
2 o 5?
Monday po.
Monday po.
Once a week lang?
2:30 to 5:30, sir. Once a
Yes
week
po.
lang po.
Ba't di natin gawin once a week lang sa atin?
Internal na lang, sir.
Ha?
Joke lang.
Hirap nito. After nito, may kasunod pa ako eh. Pero hindi ko alam kung ang maganda doon, pwede kong gamitin yung mga lecture ko last semester. So, titingnan ko ano yung reaction nila. Okay. So, any more question before we call it a day? So, thank you at nag-enroll kayo dito. And I hope I will try my best to share yung knowledge ko sa at least spectroscopy. And if ever you need other aspects, just let me know. Okay?
Thank you din to, sir.
See you on
Thank you po, sir.
Friday sa Dr. Aga Lab. Okay? Bye.
Thank you, sir.
See you din po.
Thank you, sir.